Hello, I'm Katie Johnson. I was at the Southwest qualifier a couple of weeks ago. I was helping the teams there with LabVIEW, and while I was at that tournament, I had a presentation that I was going to give there, but there wasn't time. So I am instead turning it into this podcast that I am emailing out to all of you. So the things that I'm going to cover in this podcast are the basics of the LabVIEW environment, and then I'm going to get into some more complex and advanced things that I find useful when programming FTC robots. So the very first thing that I'm going to do is just create a new program. So create program, and then I'm going to do the FTC arm and gripper robot project and just create that. And what I'm doing here is telling it to save to my desktop because the place that it automatically saves to doesn't work properly. It doesn't have permission to write to it. So I'm instead saving it to the desktop and create. So the very first thing that I'm going to be covering are the various tools that are useful when programming for FTC. And this is just taking a second to load. Okay, so here's the Robot Project Center, and I am just going to open that autonomous mode VI that is pre-generated. Almost there. There we go. Okay, so like I said, the first thing that I'm going to be covering are the various tools that are useful when programming FTC robots. So I'm going to go ahead and open up the Tools palette. So very first thing, you can turn on automatic tool selection that automatically just selects the tool that it thinks you need. When you hover over a wire, it brings up the wiring tool, etc. Personally, I like working with it turned off because then I can just manually select the tools that I want, and I find that easier. So the very first tool is just your standard cursor, and then you can hit the space bar to change to your wiring tool. These are the two most used tools when programming FTC robots. So standard wiring tool. Alright, then you can hit the tab key to cycle through some more used ones, and so the first one is your text key for commenting code. So commenting code is very, very useful when you're writing code and you're either going to be coming back to it later or showing it to someone else, and you're going to need to have it easily readable, and you want the reader to be able to figure out exactly what it does easily. So commenting code is great for that. The next thing is the wiring tool. Once again, I'm hitting tab to get through these. And the final one that comes up by hitting tab is this pointer finger hand. And so this is just for selecting items from drop-down menus and such. There's one other tool that is useful when programming FTC. It doesn't show up when cycling through the tools on the keys because it's less used, but it's this full hand here, just for dragging your code around the screen. Alright, so those are the tools that are useful for FTC. I'm going to go ahead and close that palette now. The next thing that I want to cover is the context help window. So the context help window can be opened on a Mac by hitting Command Shift H, and so that opens up your help window. So when you mouse over a sub-VI, one of the blocks on the diagram, the context help window adjusts to tell you what that sub-VI does. So this one waits the specified number of milliseconds, and then the help window also lists all of the inputs and outputs for that sub-VI, so all of the wires flowing into it and out of it. So you can mouse over a couple of different things, and it just explains what they do and lists inputs and outputs. Usually, if you have a question about a sub-VI, this is enough to answer it, but if it doesn't answer your question, you can click on the detailed help window, on the detailed help button, and this opens a window telling you exactly more detailed what it does. So it gives you examples and just lots of information on it. So the help window is very, very useful. Personally, it gets in my way and then I close it and forget about it. So if you can get in the habit of using it, you'll be one step ahead of me. Okay. The next thing and the final thing in the LabVIEW environment that I want to cover today are the buttons here at the top of your block diagram. So the first two are download buttons. The first one downloads and runs the program. So downloads to the NXT and automatically starts running it. The next one is deploy. This one only downloads it to your NXT, but it does not run it. The next couple buttons aren't very useful generally when programming FTC robots. They're more for other styles of coding, so I'm not going to cover those today. The next ones that are useful with FTC are these align objects buttons. So if you have a couple of sub-VIs that are out of line like this and you want to clean up your diagram, you can select those sub-VIs that are out of line and then go to the align objects and select different ways that you want to line them up. So vertical centers, and now they're just in a nice neat line, and it makes your code a lot easier to read and prettier. So the next button up there is pretty similar. When you have sub-VIs that aren't evenly spaced like that, you can select them and go up to that button, distribute objects, and then you can select different ways that you want to distribute them. So I'm going to click horizontal centers, and so now they're just evenly lined up on those centers. So both of these buttons are very, very useful when manually cleaning up your diagram. The final button that's useful when programming for FTC is this cleanup diagram button, and so you can select a small portion of your code to clean up, and it cleans it up. This cleanup diagram button is generally most useful when you have sections of code like this that are very straightforward and easy to line up and such. When you have more complicated code, it's often better to clean it up by hand. So if I clean up the entire block diagram, it does its best, but sometimes it's pretty difficult for it to do, and so personally I like cleaning my diagram up by hand better, but it's up to you. So I'm going to go ahead and undo that for now. Oh. Alright, so this error is not going to affect my presentation today, so I'm just going to go ahead and hit OK and ignore it for now because it isn't going to affect me. I've never had issues with it when programming FTC before. I can just ignore it and it isn't a big deal. So hopefully you can do the same. Alright, so I've covered everything that I want to in the basic LabVIEW environment. So what I'm going to be getting into next are a couple of things that are very helpful for me personally when I'm programming FTC robots. They are a bit more advanced, so just heads up. But feel free to keep watching. You can, even if you are a LabVIEW beginner, it might be fun to see what it is. So I'm going to go ahead and close this autonomous mode. Alright, and so I'm going to create a new VI. Okay, so the first thing that I want to talk about is shift registers. So shift registers are used with loops in LabVIEW, and I'm going to go ahead and write a little bit of code before explaining what they do. So now I have right-clicked on the edge of this loop, and I'm going to scroll down and select Add Shift Register. Right. So this here is a shift register. Basically, what it does is when you run a loop, you can wire something into the shift register here, and then on the next iteration of the loop, the next time that the loop runs, it is going to remember that value or whatever you wired into it. So I'm going to write a little bit more code, and then I'll explain more in depth what it does. Okay, so I'm going to go ahead and clean up my diagram. Beautiful. Okay. Alright. So what this code is going to do is take this shift register. The first value in the shift register when the program begins is going to be 0. This is called initializing the shift register, and so I've just wired in the value that I want it to start at so that it doesn't remember values from the last time it ran the program, because that can screw it up. So it starts out with a value of 0 in here, and so it has this wire, value of 0. It's going to plug it into the addition function, add 10 to it, and then output this wire with a value of 10 into the other side of the shift register. Then, so the loop is run once now, the next time that it runs the second time, it's going to have a value of 10 in this shift register. It's going to take it, add 10, and then it's going to plug in a value of 20 to the other side, etc., etc. So this is just going to continue counting up by values of 10. This is super useful for various things. I've probably used it most when I'm programming my robot to use a gyro for turning and such, and so when doing that I need to convert a rate, and so I need to know exactly how long it took for my loop to run, and so I plug times in and remember them and count them up. So these shift registers, even though this example might not be very useful, they are extremely useful once you start getting into more complicated coding. Alright, so shift registers are done. Okay, so there's just one last thing that I want to cover in this presentation. It's another more advanced thing that I find useful when programming FTC robots, and that is sub-VIs. So sub-VIs are basically when you take a chunk of code, a large section of code, and you condense it down into a single block. And so these are very useful, I found, in two different instances. One, when you have a section of code that you use in lots of different places, and so instead of having to write it over and over again, you can just turn that code into a sub-VI and place that single block on the diagram every time that you want to use that code. The other time that sub-VIs are useful is when you have a lot of code on your screen to the point where it's getting unreadable, and so you can condense sections of it down into sub-VIs so that everything fits on your screen better and is a lot more readable. So there are a couple different ways to create sub-VIs. The first is selecting the section of code that you want in your sub-VI, and then going up to Edit, Create sub-VI. And so that has condensed that down into that single block. Usually you would put a lot more code in there, obviously, but for our purposes of this presentation, I just have that small amount of code in there. So that's one way to create a sub-VI, and this way automatically adds all of your inputs and outputs, so you can see here, to that sub-VI. So that's all of the wires that were flowing into and out of your code that you turned into the sub-VI. The other way to create the sub-VI is just to go over to your front panel, and there's this icon here in the top right corner that you can just drag onto another block diagram. So I'm going to go ahead and place this in my autonomous mode. And so now I have this code in this single block. I can go ahead and open it back up, and you can see it is that code. So, like I said, these are very useful when you have a lot of code that you want to condense down into a smaller space, and also when you have code that you use over and over again, it's very useful then too. There's one other thing with SubVIs that I want to cover, and that is up here next to the icon on your front panel, you have this connector terminal. And so I'm going to go ahead and change my code just a little bit. I'm going to change this to a control, and that causes it to show up on the front panel. And I am also going to create an indicator here. There. Okay. So now I'm going to head back over to my front panel, and I can wire this control. This is setting, sorry, just gonna juggle these windows around a little bit. So this control is setting what number you are initializing your shift register to. And so I'm going to wire this control here. I'm just going to click on it with the wiring tool and then set it to one of those boxes. I'm going to do the same thing with this indicator with the output of the shift register to a box on the other side. And now if I go over to here where I have this SubVI, I have these inputs and outputs, so I can set what I want the shift register to initialize to without having to go into that code. I can set it outside of here. So that is a very important part of SubVIs. So that's all that I have for you guys today. I hope it was helpful. If you have questions about it, feel free to reply to this email. I'm happy to try and answer them. And also, you could come to my LabVIEW office hours where I'm available to Skype with anyone who would like help, and I'll put the times and dates in this email. So, just one other thing, thank you very much for having me out to the Southwest Qualifier in Bethel. I had a lot of fun, and I hope I was able to help the teams there a lot. So, thank you, and once again, I hope I helped at that tournament and in this presentation. Bye.